In this video, we're going to focus on exponent properties and then simplifying some expressions containing exponents. So let's start off with some basic properties. First of all, the property of multiplication means if you have two exponential expressions being multiplied together, there's a shortcut to simplify that. First of all, we'll take the long cut. You should all know that 2 cubed means 2 times 2 times 2, and 2 squared means 2 times 2. So in total we have 2 times 2 times 2 times 2 times 2, which is 2 to the 5th, or 32. So hopefully from that you can see the power property of multiplication of like bases. Now when I say like bases, we're talking about those 2's. They have to be the same. The 2's in red, those are the bases, and then the yellows are the exponents. So if the bases are the same, and you're multiplying like bases together, all you do is add the exponents. So the shortcut is 2 to the 3rd times 2 to the 2nd is 2 to the 3 plus 2, or 2 to the 5th. So in general, we're going to say the property is that x to the a times x to the b is equal to x to the a plus b. So that's our first property of multiplication. Let's move on to the property of division. Let me clear this portion of the screen. And before we move on, let me go ahead and write that property next to multiplication that I just had up there. X to the a times x to the b equals x to the a plus b. Okay, division. For division, let's take a look at 3 to the 4th over 3 to the 2nd. Well, 3 to the 4th is 3 times 3 times 3 times 3. 4 factors of 3. The denominator is 3 times 3. And what we could do is do a little cancellation here. That 3, except let me change that 2 into a 3. I miswrote it. There we go. So the first 3 cancels with one of the 3's on top. The second 3 cancels with the other 3 on top, which leaves 2 3's on top, or 3 squared, which equals 9. So from that, we can kind of see what the property is. You take the exponents. Again, the bases have to be the same. So since the 3's are identical, all we have to do is take the exponents and subtract them. So let's generalize. If we have x to the a divided by x to the b, you simply subtract the powers, so that's x to the a minus b. So let me squeeze that in up here on our outline. X to the a divided by x to the b equals x to the a minus b. Okay, our third basic property. Let me erase this. Clear some space. Okay, power to a power means, example, let's go 5 to the 2nd to the 3rd. So inside the parentheses we have a power, and outside the parentheses we have a power. So let's deduce this property. Well, if you're cubing 5 squared, you're taking 5 squared times 5 squared times 5 squared. Of course, this is the long way to do it, but it kind of shows how the property works. Now 5 squared times 5 squared times 5 squared, we can go back to the first property of multiplication, which says if you have like bases, which we do, all the 5's are the same, you just take the property, or take the powers and add them together. So that's 5 to the 6th power. And we could take our calculator out, or just think about it. 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 is 3125, times 5 is 15,000 something or other. Let's see, how about 15,625? I'm pretty sure that's what it is. Without digging out my calculator, we'll go with that. So our property, taking a look at this example, 5 squared cubed, let's write that as x to the a parentheses raised to the b power. Well, notice in our example we had a 2 and a 3 as our powers, and then it became 5 to the 6. So what you do is you multiply those powers together, so it's x to the a times b. So that is our third property, basic property of powers. And now we'll start with some more complicated examples where we're going to simplify expression using those properties. So let's go with the clean page. Let me scroll down. So we have some workspace here, and I'll make up a problem. Let's go with, how about x to the second times x to the third times y to the fifth all over x to the fourth times y to the third. Alright. Now at this point, what you would want to do first is try to simplify the numerator and denominator separately as the first step. So in the numerator we have x squared times x to the third, which is x to the fifth. We use that property where we add the exponents, times y to the fifth over x to the fourth, y to the third. Alright, now we're dividing, so if you remember the property, like bases, you subtract the powers, so we have x to the fifth over x to the fourth, so we subtract those powers, and you end up with x to the 1 on top, and then y to the fifth over y to the third, subtract those powers, and we have y squared. So we'll write this in more simplified form, simply as xy squared. And we used two of the properties in that problem and ended up with our simplified expression. Let's try another one. Let's go with x to the 6th times, let's stick a number in there too. Let's go 14x to the 6th, y to the third, y to the third raised to the second, over 2x to the third, y to the fifth. Alright, numbers just work regularly. They don't have any special powers or properties with exponents. 14 over 2 is just 14 over 2, or 14 divided by 2, which is 7. So we can cancel our numbers first. And then on the top we now have x to the 6th. Y to the third squared is our power to a power property, so that becomes y to the 6th. And that is all over x to the cube, y to the 5th. Alright, now we're simply dividing, so we subtract our powers, x to the 6th over x to the third. We end up with x to the third, and y to the 6th, y to the 5th. 6 minus 5 is 1, or simply y, and there's our second answer. Okay, it's time to go crazy with a complicated example here, so let's try a problem like this. Let's go 2x to the third, y to the second, cubed times 6xy over x to the second, y to the second, cubed. Alright, let's start in the numerator again, and since we're cubing, in this first part, we're cubing the set of parentheses here, so that exponent of 3 applies to each individual factor within the parentheses. So 2 to the third means 2 times 2 times 2, which is 8. X to the third raised to the third, we use our power to a power property and multiply those powers together. So that's x to the 9th. Y to the second to the third, multiply those and get y to the 6th. Right? That's going to be times 6xy. Then when you get real good at this, of course, you can do all these steps simultaneously in your head. But for right now, let's put in a few steps so we don't get lost. Alright, still on the numerator, 8 times 6, 48. X to the 9th times x. Of course, there's 1 on that x, so that's x to the 10th. And then y to the 6 plus 1, or 7. Now on the bottom we have a power to a power also, so that 3 gets applied to the x and the y both. So x squared cubed is x to the 6th, and y squared cubed is y to the 6th. Alright, the 48 stands alone. He doesn't get canceled with anybody, so he's going to end up in the final answer. X to the 10th over x to the 6th, we use our subtraction power properties, and it ends up being x to the 4th, and y to the 7th over y to the 6th. Subtract the powers and get y to the 1st, or just y. Final answer, 48 x to the 4th y. Done. So those are the main three properties of exponents that you need to know and be able to work with. So We're going to conclude this video, and in the next video we're going to examine negative exponents and see how they work and combine those with the properties we just saw in this video. That's all for now.